What is a generation clock in a leader and follower architecture in a distributed environment? Let's say we have three nodes. N1 is the leader and N2 and N3 are its followers. There is a client C1 which sends a request R1 to the leader N1. The leader updates the data on its own end and tries to replicate the data to its followers, but before doing that it gets crashed. Now what will happen, the followers N2 and N3 won't be able to receive any heartbeats or any updates from N1, which will make them believe that the leader N1 is down or it has got crashed, right, because of some reason. So what will happen is they will participate in a leader election process and will get a copy of the data from the basically most updated node in the system, right, which is N1 right now. So they will basically kind of look at the right basically log entries. Log entries of the most updated node and will update their their system. So they will also be having these entries on their end. Right. Okay, this will happen when the leader election the leader is elected, during that process. So let's say N3 was elected as a new leader. Now let's say there is a client C2. Hold on, I have drawn it wrong. Right. Now let's say there is a client C2 which sends a request to the newly elected leader N3. N3 updates the data in its log entries and tries to replicate it to its followers, which is N2 as of now. N1 is down. So this update will be made here in its log entries. First the log entries of N3 will be updated. So it has 1 comma R1 and 2 comma R2. Here this 1 comma R1 is basically here this 1 is basically the index number in the log entry and R1 is the request data. Right. So when the next time N3 gets an update, it will be written at the next index, right? Similarly, when this request is sent, basically not the request, copy request will be sent only for this 2 comma R2, right? So 2 comma R2 will be sent at N2. N2 will basically update the data on its own end. In the log entries will look like this: 1 comma R1 and 2 comma R2, right? And after some time, let's say N1 gets up and it still is thinking that it is the leader and tries to copy this data to its followers. It sends a request for 1 comma R1, right, to both its followers. But at this point N2 and N3 will get confused as this is a situation of conflict, and this conflicting situation is solved by using an integer number this integer value keeps track of the version of the leader selected, right? For example, initially when for the first time a leader is elected, this value is set to 1, and when this leader for some reason gets down, a new leader is elected. The new leader basically reads the log files of the most updated node in order to copy the data, right? And from there it understands that the old leader's value was 1, and it needs to increment this value. So the new leader will get a value 2, likewise the next leader will get 3, 4, like that. So basically these values basically help to resolve this conflicting situation, right? So here how we can use this integer value to solve this situation. This integer value is basically called as the generation clock, right? If we alongside the data in the log entries at a particular index, if we also maintain an integer value, the generation clock, we can get rid of this conflicting situation. So alongside the log entries, I am keeping an integer value 1 here, as this was the leader. It was elected for the first time in the system, right? It was initially 1, and they will also get this value from the most updated nodes or log entries, right? And for the next time when n3 was elected as the new leader, this value would have been 2 here, right? So I have written it incorrectly here. I mean, not incorrectly, it should be it should be written in a way that would depict the order when the entries were made, right? So it is not incorrect or inappropriate. We can understand that like this: before comma it was written, I mean in the list it is written first, so it was written earlier than the entries written later in this list, right? So this basically can be further updated like this. It was written like this with the generation clock value 1, and later one more entry was made, 2 comma r2 with generation value 2, right? So this number is the index number, this is the data, and this is the generation clock, right? So when this copy request will come with generation value 1, it will locate the generation clock in the most recent entry in its log and will compare it with the generation clock value received in the request, right? If it has a value later than the value received in the request, it will discard the request, right? Otherwise it will accept the request. So in this case this request will be discarded. Similarly this request will also be discarded, right? So this way this conflicting situation is solved.